consumers because it didn't need to be polished. And today, the concept hasn't lost its luster. Stainless steel is made to look shiny and new, even though it starts from scrap. Old stainless steel is recycled to make new, giving trashed sinks, pots, and other refuse a new lease on life. Tons of scrap steel are fed into a roaring furnace, along with chrome and nickel alloys for added strength and rust-proofing. Enormous electrodes heat the mix to the melting point, creating a dramatic fireworks display in the process. After several hours, the molten mix goes into a refining furnace. Pipes blast in argon gas and oxygen, converting some impurities to gas, and causing others to float to the surface for easy removal. A technician regularly checks the temperature and takes samples to make sure the chemistry is right. A bit more scrap is added to bulk up the mixture as it melts. The scrap also causes a chemical reaction that helps to fuel the refiner. The bubbling steel soup now flows out of the refining furnace. Rollers guide it as it's cast into a long mold. The result is a 75-yard-long ribbon of steel. Torches cut it into shorter chunks called slabs. A worker writes identification information on each one using chalk designed for hot surfaces. Then, the slabs are hoisted over to another station to await further processing. After this break in production, the slabs are reheated to soften them up for more processing. By now, a rusty scale has accumulated on the steel surface. Workers pressure wash it away without cooling the hot metal. The slab shoots back and forth through a machine with rollers. A constant spray cools the rollers as they stretch the steel longer and thinner. It's now over 650 yards long, the length of a couple of city blocks. A spray of water cools the stretched steel a little, but not too much, because it needs to be soft and flexible enough for coiling. This spool coils the strip tightly like a roll of toilet paper. Then, the roll is transferred to another station. Here, the steel goes into a hot acid wash that removes the scale that's built up since the last cleaning. Burners in this machine also heat the steel, then slowly cool it. This relieves stress in the metal, softening it for further processing. The steel is now unwound into a machine that rolls it to the customer's specified thickness. Rolling the metal when it's cold also hardens it and closes its surface pores, making it shine. After one last cleaning, the stainless steel strips are gleaming, and the chrome in this steel combines with oxygen in the atmosphere to form that rust-preventing oxide film. Finally, rotating knives trim the edges and slit the steel to various widths, again to meet customer specifications. This job is now done, and it's a brilliant finish indeed. Up next, meet the starting lineup at a football helmet factory is a victory in itself. When we return, bringing resin figurines to life. Figurines are made of many materials, from porcelain to plaster to resin. Not the kind that comes from trees, but a synthetic resin, a kind of plastic. It's affordable, lightweight, and easy to use, making it the material of choice for many artists and craftsmen. Each figurine in this collection is cast from a mold of the original sculpture, then hand-painted. This character is a 19th century federal marshal. Working from period photographs of her subject, the artist makes a sketch she'll use as a model. She needs plastic-based clay so it's easier to sculpt. She works on the facial features, constantly referring to the photographs. She usually starts with the figure's head and then adds it to the body. She works from more photographs to create his rifle. It's a delicate piece, so she sculpts it separately before setting it onto the figure. Bearing the artist's signature, it's now ready for casting. First, the sculpture bakes for 30 minutes at 275 degrees to harden. Then, workers cover it with a thin layer of releasing agent so it won't stick to the production mold they're about to make. They place a wall around the piece, tightly seal the base to prevent leaks, then pour in a silicone rubber mix. In 2 days, the rubber hardens enough to hold the shape of the sculpture, but is still flexible enough that workers can remove the original artwork without damage. After removing the retaining wall, suction is used to gently pull the piece from the mold, which retains the sculpture's shape down to every last detail. Now, figurine production can begin. Workers fill the mold with a mixture of resin and flour made from ground pecan shells. This colors the resin and makes it stronger. The mixture sets in less than an hour, and out comes the first of many figurines, an exact replica of the original artwork. The base is sanded to level it. Then, it's stamped with the figurine's name, ID number, and copyright information. Resin is an ideal material for casting because it captures all the details of the original artwork. It creates lightweight, durable reproductions that can be finished in a variety of ways. Here, the first artist coats the figurine's broad areas with acrylic paint. Working color by color, she uses various brushes depending on the areas she's painting. She finishes up with the smaller details. Then, she passes the figurine on to the next artist. This second artist fills in the facial features and other fine details. She starts with the whites of the eyes, then views the figurine from all angles to make sure she hasn't overlooked any tiny detail. Her fine brushwork on the facial features is what truly brings this figurine to life. Bass Reeves' U.S. Marshal is just one figurine in this series that proudly honors the contribution of African Americans in shaping the history of the United States. Once Marshal Reeves passes inspection, workers wrap him up in protective bubble plastic. Each piece in the series comes with a certificate of authenticity bearing the artist's signature, as well as the name and life story of the person the figurine portrays. Collecting this set of resin figurines isn't just for the knick-knack lover. This is indeed affordable art for the history buff. Small-scale figures that pay a large-scale tribute to African-American pioneers. Coming up, behind the scenes of a real test tube bird. Their size, shape, and function run the gamut, ranging from beakers and test tubes to petri dishes and vials. Mixing, measuring, storing, or sampling is all in a day's work for a piece of laboratory glassware, built to withstand even the most potent of chemical concoctions. Many scientific breakthroughs are born inside laboratory glassware, the containers scientists use to hold samples for chemical experiments. The glassware starts off as thin glass tubing, stacked by size, weight, length, and diameter. Workers select the correct size for the culture tubes they're about to make and place them in a magazine. As it spins, it drops a tube into each slot on a cutting bed. Then comes the flame. When the heated tubing contacts the wet steel blade, the thermal shock results in a clean separation of the glass. The tubes get a second thermal shock treatment which cuts them to length. Then it's on to the glazing bed. A glazing burner shoots out 1200-degree flames. The heat melts each tube at one end, forming a lip called the glass bead. Just 2 seconds of heat splits the tubes in half and forces the glass bottom of each tube to close in on itself. The finishing fire smooths out the closure. Then, a small amount of air is shot into the open end of the tube to form its round bottom. Now the tubes head into an annealing oven side by side. They bake for about 15 minutes at 1200 degrees. This strengthens the glass so it'll better resist cracking. The heat also sterilizes the tubes. Once the tubes cool, workers collect and pack them. Here, they're making pipettes, long tubes that labs use to transfer fluids. A flame heats the glass to form an indentation which determines the flow rate through the pipette. A wider flame then heats the glass, making it soft and malleable. Large rollers tug at the sides, drawing the soft glass to form the pipette's tip. Now for the other end of the pipette. Thermal shock is used to cut it to length, and again, a glazing burner forms a glass bead along the rim. A cutting wheel slices through the tip end, creating 2 tubes of identical length. This production line makes vials. These gizmos, called top turrets, feed large glass tubes into a machine. First, a punch-out burner heats the end of the tube to create an opening. Then, a steel pin widens the hole on the upper part of the vial. A forming die squeezes the heated glass to sculpt the shoulder, while a steel plug rises from the bottom to open the vial even wider. Then, a second forming die shapes the neck. Next, a parting burner splits the vial into 2. A bottom turret plucks the newly created half and draws out the soft glass to lengthen it. Fingers inside the turret prevent the glass from breaking. All that's left now is shaping the bottom of the vial. A burner forms a concave base in less than a second. The vials now slide down to what's called an afterformer machine. Here, suction cups lift and place each vial into metal grooves on a printer bed. It's a basic silk screening process, with a squeegee pushing paint through the screen's holes onto the vial. Grippers place the vials on a rack headed for the oven, where they'll bake for about 20 minutes. Finally, a robotic arm whisks the finished vials to packaging. From there, it's off to a blood bank, a hospital, or chemistry class. If you have any comments about the show, or if you'd like to suggest topics for future